In this video, we are going to continue our conversation about HVAC schematics, and we're actually going to build upon our last schematic. Now, remember, in our last schematic, we had two power supplies because we basically had an indoor unit and an outdoor unit. The indoor unit had the cooling thermostat, 120 volts, an evaporator fan, actually two evaporator fans. One was a split phase, one was a PSC. And we can tell by that by the split phase has start components, in this case a current coil relay that takes out the start winding, and the other one just had a run capacitor that stays in the circuit at all times. Now the cooling thermostat controlled a compressor contactor, which was connected mechanically to the outside circuit, which is 240 volts, and everything outside or in the condensing unit cycles on and off based on this compressor contactor. By the way, this is the same principle that applies with air conditioning and split systems you might find in someone's houses, except we add some additional components to it so that we have some low voltage, because low voltage is safer to handle. Okay, now, so this is the diagram we're going to build on. The next step in this whole thing is to realize that we don't have any safety controls in here. If there's a refrigerant leak, or if there's a high pressure situation, or anything that happens with the pressures, there's no safety to turn this circuit on and off, okay? So we're going to introduce two new symbols in schematic 9. Okay, we're going to introduce a low pressure switch and a high pressure switch. Now these pressures are important because they actually sense the refrigerant pressures inside the copper tubing and will turn the system or open and close based on those refrigeration pressures. Okay, so I'm going to come back over here to my schematics page that I've been sort of creating schematics on all the way along. And we're going to start out by, let's create again. I'm going to start off with the basic switch because that's what all of these things are. Okay, then I'm going to alter it a little bit because I'm going to create that little line off the bottom that I just created there. And now I'm going to, unfortunately, have to hand draw in a little arc like that. Okay, and I got the color wrong on that, so we're going to change that color real quick. Let's make it the blue that we've been using for everything else. Okay, now this is going to be a high pressure switch. Okay, this is going to, if you take a look at this switch, this is going to open on a rise in pressure. Okay, and you may see these drawn with this line closer together, but in this case, this is a high pressure switch, open on rise in pressure. So I'm going to label this. Okay, so we're going to go ahead and label this. Let me move that over a little bit. Now, we have another version of this, okay, that's a low pressure switch. We want it to open and a drop in pressure. So I'm going to again start off with my line like I have been. Okay. And instead of going up, well, I'm going to come down. Okay, and again, I'm going to put in my center post there. And then, as I said, I'm going to have to, unfortunately, with PDF Expert, which is what I'm using here, you can't really get a good arc out of anything. So let's go ahead and label this. We're going to call it LPS, or low pressure switch. Now, the high pressure switch is normally used Okay, it's normally a normally closed switch that's used to sense a rise in refrigerant pressure past a safe level. Now, things that can cause a high pressure switch to open would be like a dirty condenser or a non-working condenser fan or something that's causing the heat not to reject off the system. It can also open a blocked refrigerant line, but that's less likely. The low pressure switch will open if there's a leak in a system, okay, or the pressures drop below the safe operating pressures for the compressor. Remember, refrigerant is what actually cools the compressor. So these are the two switches we're going to add to the schematic. So what we're being asked for, okay, is EFM1 and EFM2 run all the time. Okay, we have a cooling thermostat, low pressure switch, high pressure switch. EFM1, EFM2 run all the time. We have a condenser fan motor, 1 and 2. Now, this is all 240 volts, again, so we have an indoor and outdoor unit. So, this is the same sequence that we used in schematic part 8. Okay, so I personally am not a fan of redrawing if I don't have to redraw. So what I'm going to do is I am going to, oops, that isn't what I wanted to do. So what I want to do is I want to capture basically everything under my text block. I'm going to copy that and I'm going to go ahead and paste it over here. And this may just take a moment to paste. Okay, so it's pasted over here. Now, when we put pressure switches into systems, we are specifically concerned about protecting the compressors, okay? Because that's really what we need to cycle on and off. The rest of the system, you don't have to cycle on the pressure switch. So we're going to make a couple small modifications down here in the bottom portion of this diagram to allow us to cycle the compressors on and off. Okay, the first thing I'm going to do is just to give myself more room. Okay, I'm going to go ahead and move compressor 2. Okay, over to this other side. And the only reason I'm doing that is because I need to be able to, I want to connect the wiring a little bit different. Okay, so even though now I am not coming back to the whole starting point, I'm not coming back to that L1 directly with this wire, but it's the same principle. It's getting direct line voltage. These two motors are not in series. Okay, if you look closely, this one's getting line and that one's getting line. Now, this wire right here is the one where I'm going to add my pressure switches, okay? So we're going to put my low pressure and high pressure switch in series before this compressor motors, okay? Because safety switches always go in series. If you have it next to each other, if the low pressure switch opened without the high pressure switch opening, I would still be driving those compressors with current and voltage. But if they're in series with each other, both switches have to be closed for it to work properly. So I'm going to come over here. I'm going to grab my low pressure switch first that I just created. And I'm going to come over and put it in here. Okay, that's my low pressure switch. I'm sorry, my high pressure switch. Then I'm going to come back over here and I'm going to grab my low pressure switch. Okay, and I'm going to come over here and I'm going to paste it in over here. And you can't control where these things paste, so you just have to move them around. Okay, I'm going to fix this one over here. Okay, so what I now have is I have a high pressure switch and a low pressure switch that is in series with this two. Okay, I'm going to put high pressure switch, low pressure switch. Now what they are is they are now in series with this compressor. So as long as both of these are closed, which would be normal operating conditions, the compressors are going to run. But either of these switches open, the compressors is going to cut off. Everything else will continue to run normally based on the cycling of the thermostat. So again, when we look at the motors, you see that all motors are in parallel. None of them have a common going to another line or run of a motor. And we have two voltage supplies, an indoor and outdoor. But again, the two components that we added to this circuit is the high pressure and low pressure switches. There's one more pressure switch I want to talk about that you might see on occasion. So I'm going to copy this one, the low pressure switch, real quick. Okay, because I want to show this one to you as well. And I'm going to just put it over there. Okay. Occasionally, you will see what we consider a combo pressure switch in a circuit. What a combo pressure switch is, it is one component that includes both a low pressure and a high pressure switch. Okay, so again, occasionally you will see something that looks like this. This is a combo pressure switch. And it will have a high pressure and a low pressure control in one unit. Now, just again, a word to the wise, when you're troubleshooting these things, high pressure switches are normally manual reset. Low pressure switch are normally automatic reset. So if the situation corrects with a low pressure switch, it's going to close and fix itself. Or if there's a situation where the compressor comes on, pressures drop below a safe level, compressor shuts off, it will cycle on and off on a low pressure switch. On a high pressure switch, with one exception, they are normally manual reset because it's an unsafe condition to the point where the pressures could actually rupture refrigerant lines. So, did we meet our guidelines for this diagram? Yes, we added a low pressure switch, a high pressure switch. Okay. Everything else really remains the same. CSIR, condenser fan and compressor 1, CSCR. Okay. Condenser fan 2 and compressor 2. So, again, basic difference is the pressure switches. Senses the pressure inside refrigerant lines, and they're wired in series. All safety controls are wired in series.